So following on from the introduction, these 4 great tapes, we're going to move on to tape number 1. This is good old Captain tape now. A lot of you will know this one. It's used widely on printed circuit boards in lots of different situations, and within this video I'm just going to show you a few of these situations now. So what I do, get on with a few examples of this where I like to use this tape, and then we move on to the other tapes after that. Right, so come on to the first tape within these videos. We're going to use Captain tape. Now we're going to get this IC removed. So what I'm going to do with Captain tape is cover the tops of them surrounding components. Now Captain tape should work well here. The components aren't too close to the component being removed. If these were a lot closer and this component might have a lot more pins, might take longer to remove, I've definitely got a preferred tape over Captain tape, and I'm going to show that later on in the videos. But for this one, Captain should work well. So what I'll do quickly off video, get this taped up. I'm using 3M Captain tape, so it's a branded tape. So like I say, I'll get it taped up and then we'll get it removed and see the results. Right, so as you can see off camera, I've quickly covered the surrounding components with the Captain tape. I also added some rework flux just along both sides of the joints just to aid the flow of the solder. So let's bring the hot air gun in. Now, like I said earlier, Captain tape should work well with this because these components aren't too close to the device being removed. But you'll see later on in the videos the tape I actually prefer when I do this sort of work. Let's just circle this device, get all the joints heated up. Just be patient. It should be off any second. Let's get that off. Let's just lift that off. So all the pads perfectly intact. Small amount of excess solder is dotted in there, but that can be removed after. Oh, it's actually flux. So that's yeah, it's come off quite well. So let's get the tape peeled off. Let's have a look at the results. So I'll get all that off in one go. So as you can see, all the surrounding components are perfectly intact, no movement at all on them. So that Captain's done a good job there. So I never do hot air rework without one tape or another, but this tape's fine for this example, but you'll see later on in the videos the actual tape I prefer for more difficult removals. So anyway, what we do now, just quickly move on to another Captain example. I'll show you 4 or 5 different examples with Captain, and then we go on to the other tapes after that. So another great use for Captain tape is this one I'm going to show in this clip. Now if I was attaching a wire to this second pin in, it can be fairly easy to accidentally catch the pin either side and form a large short, and it can be sometimes difficult. You haven't got the right equipment to remove that short. Now with Captain tape, I'm going to hopefully make this procedure easier. So what I do, I quickly take this up off camera and then we'll rejoin you when we do the soldering. Right, so what I've quickly done off camera, I've attached the Captain tape to the pins either side, just covering up them 2 pins either side of the wire we want to solder. So if your iron accidentally lays on top of these 2 pins, the solder won't adhere to it. So you should just get the joint on the one you desire. So let's just turn that around slightly. So you can see the gap between the wire and the pin. So let's get it soldered up now. I'm just going to add a small amount of rework flux on top of there, just to aid the solder flow. And we'll get this soldered up. So I'm just going to load a small amount of solder onto my iron tip. And we go into the joint and hopefully get this soldered in one go. So hopefully, just going to zoom in there slightly. You see the solder nicely attached all the way down to the base of the pad. So that's what you're looking for. So even if I would have laid it on to the pins next to it, the solder wouldn't have taken to them, thus avoiding the short. So like I say, laying Captain on the pins either side of the wire can give you great results. So what I'll do, I'll get the tape peeled off, clean this up. I'll take some photos of all the methods I show throughout this video. And yeah, that can aid some people, so it's just another good tip where you can use Captain. Anyway, let's carry on with the other clips. So moving on now to a method that's helped me out a lot over the years. I'm going to use Kapton tape to control the flow of solder and how much solder I apply to the pad. Now this is just an example board. Maybe if you've got an RF circuitry board and this was a long trace, you wouldn't want the solder to spread too far down because it can affect performance. So I'm going to show you in this method how you can control the flow of solder and the spread of the solder using Kapton tape. So I'm quickly going to do off camera. I'm just going to quickly get this taped up, then I'll rejoin you when we're ready to do the soldering stage. Right, so quickly off camera, just shaped a bit of Kapton tape around that wire, so hopefully when I get this soldered up I should just get the solder within that area there where I basically cut the Kapton away. So if you've got traces like this on RF boards and you don't want the solder to spread too far down the trace, just put a bit of Kapton over at the point you need it to stop. As long as the Kapton's down tight, the solder should basically stop at that point. What I'm going to do on this one is get a small amount of flux added to the joint where we're going to do that, and quickly get this soldered up. So it's not critical on a lot of boards, but in some cases too much solder or too much solder flow can cause you issues. So yeah, it's just a good method this, where the Kapton can really help you. So just get this soldered up. That's basically, just get a small bit more on there. As you can see, got the perfect solder joint covering the wire with no spread down onto that pad. Just get this tape removed and see what the end result looks like. So I'll push the Kapton down quite tight, so it's pretty tricky to remove. And that's going to give you a perfect amount of solder. So it's not too critical on lots of boards, but there is times when you will need to maybe stop the flow going too far down. Just clean some of the flux away. Let's have a look at the end result. So as you can see, perfect amount of solder, and it hasn't spread at all down the rest of the pad. Like I say, if you need to control the solder flow, Kapton can really help you out in that situation. So anyway, we'll just move on to the final two examples, and yeah, we'll see how they go. Right, so here's another situation that I've come across many times in the years I've been soldering. Lifting pins. Now I've shown how to lift pins in one of my other videos, so I won't show it in this. So what I've done, lifted the pin off the pad underneath, and then I isolate the pad with Kapton tape, just in case if you was attaching a wire to that pin, for example, and the pin in the future got pushed down, you don't want it reconnecting with the pad. So like I say, simple bit of Kapton tape all the way back to front, totally covering the pad, and any accident in the future where that pin may get pushed down, you're safe in the knowledge that it won't reconnect to that pad. So yeah, that's just another common situation where I've basically used Kapton tape. So what I'm going to do is move on to one more example, and then we'll carry on with the tapes after that. Right, so just show you this one last example where I like to use Kapton tape with PCBs. There's lots of other situations I could have shown, but I thought I'd show these 5. So on this one, doing a modification on the board, I want the wire to go to a different point in the board. So all I've done, taken the resistor off R19, replace Kapton tape on top of the pad, replace the resistor, so obviously the resistor joint and the pad underneath are now not connected. Kapton's protecting that. Then I've run the wire to a new point, and I can also hold the wire down with Kapton tape if you haven't got any glue, for example, so there's a bit of a bonus there. So I also done this method for QFNs, for example, taking the QFN off, covered up the pads underneath I don't want connected to QFN, and then replace the QFN. So it's a good isolating method this, using the Kapton. So yeah, it's just one last example that I typically use when I'm doing modifications. So anyway, I hope you enjoyed them Kapton demonstrations, and yeah, we move on to the next tape now. So move on now to a tape that I've shown in one or two of my previous videos. This is copper foil tape. Now it's really helped me out in certain situations. Like I say, I've shown it before in one or two of my videos. People have quite liked this tape. So if you haven't seen it, I just thought I'd show you a couple of examples of this where it can help you, and yeah, hopefully you enjoy these. Right, so moving on to the first repair using the copper tape and how it can help you out your PCB problems. On this one, you had a really damaged trace. Now this is a clip I showed in a previous video. A lot of people have enjoyed it, but if you haven't seen it, I'm just going to re-show that clip to show you how we got the outcome like this. So like I say, if you haven't seen it, hope you enjoy this. Right, so moving on from the two traces we've just shown, come on to another trace that's roughly 1.5mm side to side. Quite a long section of the trace that's lifted in the air, starting to curl up and lift quite badly. It's only going to get worse. This part's almost cracked right through. So this, as you can see, the other side's starting to curl up in the air. So as in the previous video, we're going to get all this area tidied up, but with this one I'm going to show you a great repair trick using copper tape. So if you haven't seen this method, I think you're going to quite enjoy this one. So what we do, get this tidied up, and yeah, we'll get on with the repair. So move on now to the area. Now basically I'm just going to show you how you can tidy up both ends just by gently scoring across the trace. You don't have to go all the way through. I'll do the same at the other end. We'll get this removed and then we'll get both ends tinned up, ready to accept the new copper tape. So all you're looking to do, put a light score. So just go gently. So worth taking your time with this. Don't go too hard on the pressure, because you could go through to planes down below. What we've got to do then, because that's scored halfway through, just gently wiggle the loose trace and it should break at that point. Just be patient. Right, that's got that nicely tidied up. So just go to the other end, do exactly the same there. Again, not too much pressure. Just don't want to slip with your scalpel blade. So just 4 or 5 times, just gently. I should do it for that. Again, just try and wiggle that, just break it at that point. That's all you're looking to do. That should get that loose bit of trace off. So that's got both ends nicely tidied up. Now they're ready to start tinning up. Basically I'm just going to scrape the resist back slightly, about 0.5 mm, we'll get them tinned up. And then it's ready to accept the copper tape. Right, so what we've got here, basically we've tidied up the area where the trace was damaged. If you can see any of the inner layer showing through that missing trace section, just put some solder mask in there, just to basically reduce the risk of a short. You don't want to get a short from the top layer to the next layer down. So putting some solder mask in there will protect it if you can see the inner layer. But as we can't on this one, I'm going to start basically scraping back the resist, ready to get them tinned up. What you do, gently with a scalpel blade, just want to go back about 1 millimetre. Again, take your time. When you're doing any soldering projects, patience is king. Basically just plenty of time, no rush. I'm just going to do this one end, basically just to speed the video up slightly, but we'll get this tinned up and get it prepared. So that's all you're looking for. So you've got all the resist removed, about 1 millimetre back. And just get that tinned up. Just get that brushed away. So a little bit of flux on there. I'm going to use leaded solder for this one. So I've got my soldering iron set to about 330 degrees. And that should tin nice and quickly. So small amount of my soldering iron tip. Get that tinned up. That's all you're looking for. So basically we've got that nicely tinned up. And yeah, basically what I'll do now, I'll repeat the other end and then I'll rejoin you. And we'll show you the copper tape fitting stage. Right, it's what I've done off camera. I prepared the second end exactly how I did the first end. Got them nicely tinned up using leaded solder like I said earlier. So I've got no damage at all in there, so I've got no inner layers exposed. So this is now ready to accept the copper tape, and that's yeah, we're going to get that prepared. Right, so I've got a sheet of copper tape here. Now you can buy this on reels, Farnell, RS Components, always the ones in America, Mauser and Digikey. They sell this stuff as well. You can get variations in price, so shop around. This stuff's sticky backed, so you can either clean the adhesive off or you can just use it with the adhesive. But what I'm going to do on this one, I'm going to place just a small amount of glue underneath it just to give it added security. So anyway, easy to cut. You can use scissors. In this case, I'm just got an old PCB. I'm just using a scalpel just to cut through. Now this is about the width that I'm going to need. Just a couple of cuts and that should go through. So I should have me perfect width there, hopefully. Just get that last bit there. So that's gonna, as you can see, let's come on. There's the backing underneath, you can see. And now we're going to get that placed on the board and get it cut to length. Right, so what we got, this is basically the copper strip that I've just removed from that sheet. It's looking like it's going to be the perfect width to fit in that gap. So all you've got to do then is just keep cutting the length down till you get the perfect length. When you're replacing a damaged trace, for example with wire or a method like this, always if you can try and get the width exactly the same. You don't really, for instance, want a tiny little wire going across there, because it could be affected by the signals. So yeah, always try and match the width. So anyway, what I'll do, I'll keep trimming this down to get the perfect length, and then we'll get it glued in position. Right, so basically this is ready now to take the glue. So I'm going to use Tac Pack 382 for this one. It's a two-part adhesive. So basically just apply very small fillet of glue, so I don't want the trace to rise up too much in the air. You can lower the small piece of copper strip that I prepared earlier. Let's just get that in place. So there's an activator comes with this glue, so you've got a small amount of time. It's quite tricky this, just want to get it placed nicely central, nice and flat. Just manoeuvre it into position. Just push it all the way down. So hopefully that looks nice and central, nice and flat. It's equally spaced between the two pads. So I'm quite happy with that. Now I'm just going to apply a small amount of activator. Let's just give it a quick burst of that. So just give that a couple of minutes to dry and set, and then we can get this soldered up. So the glue's now set, so this is ready to get soldered up. Basically I'm going to apply a small amount of rework flux over the whole area. I'm going to basically move it from the centre out, try and get the whole copper tape layered with a thin amount of solder. You don't want to be too long on these because you can get quite a few fumes from some of the glues you use on PCB, so if you've got any extraction, that's a good thing. Let's just get some flux added to that. So it's just going to aid the solder to basically flow really quick. Let's just get a small amount on the iron. I'm going to hold some tweezers there. Just sometimes glue can become dislodged with heat. It's got to be really quick. Just give it a quick wipe over. You just want to get that applied at the end. And go to the other end and do exactly the same. Just going to add a small amount more flux. So again, just work your way from the centre out towards the end pad. Just give it a quick wipe over. Just try and get that whole tape covered in a nice amount of solder. So you've got a nice join there. Just going to revisit the first end. I'm just going to layer that down slightly. That's that one. So I'm quite happy there. I've got a nice amount on there, not too much. It actually looks higher than it is. So what I'm going to do now, I'm going to clean all this up, and then I'm going to protect it with Kapton tape. You can use solder mask as well, but I'm actually going to use Kapton tape for this one. So we'll get the clean up and then we'll fit the Kapton after. Right, so as you can see, I ended up with a really nice result. We've got the perfect width of copper tape matching the existing trace there. Got two nice soldered joints at the ends. I'll do a continuity check in a second between this point and this resistor up here. But anyway, with this I'm going to protect it with Kapton tape. You can use solder mask if that's your preferred choice. You've got the option. But the proper Kapton tape from Farnell, RS, etc. It's going to be really good quality. It's going to have lots of stick to it, and this will stay on there for many years. This is just an easier option rather than the solder mask. Just ease that down right over the area. Hopefully you can see that's quite a nice result. So anyway, I'll just do a quick continuity check. Hopefully we get the signal buzzing. Right, just put it on that point there. This resistor. So we've got a perfect signal going through there. So that's a fixed trace. Right, so moving on to the second example with the copper foil tape. Now this is one I've previously done in another video. Now this is going to take you through step by step on how I repaired this damaged pad underneath, the trace coming out of it. It's a really good video, and it's going to explain to you and show you the complete workings of how to do the copper tape. So if you find that video on my channel, it's called Copper Foil Tape to the Rescue, you'll see this fuse holder damaged laying up in the air, and that's going to take you all the way through how I created the shaped pad underneath with a trace coming out of it. And you can create any shapes you want. So if you were doing this one down here, you could do the copper foil shape like this. That's a good thing about the copper foil, you can shape it however you need. So if you can find that video on my channel, it's going to take you fully through how I repaired this fuse. And what you could do after, I didn't do it on this one, you could have gone over the repair with some solder mask to complete the job. So yeah, try and find it on my channel, it's going to give you a great explanation. Anyway, what we do, that's the copper foil explained. So it's a great tape, well worth getting some. So we'll move on to the next tape. We'll put a few photos up and then we'll move on to the third tape after that. Right, so come on now to this 3M851 printed circuit board tape. Now, I love to use this when I'm conformally coating my boards, protect connectors and other parts on the boards. It peels off really easily, leaving a lovely finish. The conformal coating doesn't adhere to it, so you're always going to get a really nice finish. And yeah, what I'll do, I'm just going to show you a couple of demonstrations with this tape, and hopefully you find this enjoyable, and yeah, hopefully it can help you out in the future. So what we do, get straight on with the demos. Right, so move on to the first example showing the 3M PCB tape. Now on your boards you may have a block of components like this with a surround where maybe a can's going to go over these components. It's going to go around all four sides, just about see it up there. So this is a typical example where you can protect this surrounding area with this tape. You're going to get a lovely finish, it's going to peel away really nicely. You're going to get a perfectly nice finish on all the sides of the surround. So what I've done, I've just quickly cut a strip of the tape. I'm just going to get that laid on. Like I say, you're going to get a lovely finish using this. Just get that all the way along there. Just carefully lower it down. So this tape's really good, no residues left behind, unlike masking tape where you often get residue left behind on the board, and you can get leakage underneath masking tape. You won't get any leakage of coating under this tape. So what I'm going to do quickly off camera, I'm just going to do the other 3 parts of this surround, and then we'll get some of this coated up, and we'll get the tape peeled off once it's dry and show the lovely finish. So yeah, it's a really good tape, especially for conformal coating. So like I say, I'll just quickly get the other sides taped up and then we'll get the coating on. Quickly off camera, just taped up around this section of the board, all 4 sides, so I want to keep this area free from coating. So now we're ready just to do the coating. So this, I'm not going to talk about too much about the coating because this video is mainly about the tape. I'll do another video one day about the coating. So anyway, let's just get coating applied to all around this board, all around the components within that section. Just come around there. I've got inductors in this section. They can be coated. Some components can't be coated. There's nothing in this section that can't be. Just deliberately apply it, just making sure you're getting all the nooks and crannies all around every side of every component within that area. So if you've got any coating going on the tape, it's going to be a good test when I peel it off later. Let's go one more around the edge and then we should be done. Let's got all of them sections covered. So I put a nice amount of coating all around the components. So what we do, I'm not going to expect you to sit and stare at this for 24 hours. So what we do, I'll let this dry and then I'll show you the end results when we peel the tape off. Right, so the coating is now cured, as you can see. Just about see the tape in the centre of your screen. I'm going to move along the length of this area. You can see the coating all applied all the way along the tape around the edge of that area we coated. Got the components behind, you can see the coating on them. It's quite difficult to film this, hopefully you can make it out. So I've got quite a lot, quite an amount of coating on the tape, all out that side as well. So it's quite difficult to keep this in focus. So what I'm going to do now is move the camera to the above view, and then we get this tape peeled off, and I'll just buzz out the surrounding with a continuity meter just to show you there's no coating at all on that surrounding. So I'll do that now. Right, so let's get the tape removed. So I'm going to start with this long side up here. Just please bear with me while I try and grab it with the tweezers. Let's just peel that carefully away. Just follow it along. You can see the nice line you're getting left just inside that border. So you see that nice line there, left right along. There might be some slight adhesive marks left on the border, but that's all it is. There's no coating on there at all. We'll clean that off after, just with some flux off and some PCB cleaning cloths. So we'll get this side one removed here. Again, you should get that. Getting that nice line up there, as you can see. And do the one at the other end. So it's a great tape. This is 3M851 tape. Any conformal coating I do, this is a go-to tape for me. Try and grab hold of that and just get that peeled off. So it's quite difficult to film this and peel it off at the same time. So again, you just see inside that border and outside on that one, you've got a nice line where the tape's come off. So the tape, this is a great tape, trust me. If you've never used it, definitely your stuff to go for when you're coating. Let's just get this last one removed. So the difficult part of this for me is trying to film it and get hold of the tape. So it's got that one. Right, so as you can see again, getting that lovely, if you look just inside there, getting that lovely line there where the tape's coming away. You're getting no coating at all on that. And it's basically not peeling any of the inside coating away. You can still see the details in that large trace there, that surround. So all the way around there, you've got a lovely finish just inside the border. And that's what this tape can do. And you see the coating around the components if you look carefully, so it's quite hard to film this one. It's got a small hair up there. That's all it is. So yeah, that's sort of showed the first example of this tape being removed. So if you've never used any, try and get yourself some, and yeah, you'll be really happy when you're doing your coating. So what I do, just give it a quick continuity check, basically on that surround. So wherever I'm going to buzz out on there, it's going to clearly buzz. There's going to be no coating anywhere on that. I could go all the way around it, and it's going to be the same result. And that's that's what you can get with this tape. So yeah, like I say, if you haven't used it before, get yourself some, and you'll be really grateful you have. Anyway, what we do, just going to move on to one more example of this tape. I'm just going to do a connector and show you on that one. Right, so just coming on to one more quick example showing the 851 tape I used to protect my parts during conformal coating. And I've got this surface mount connector down here. I've pre-loaded the two sides of this connector with a tape. So I'm just going to carry on wrapping it around the base. Now you could use this same method if you was doing your Ethernet connectors, box headers, USB connectors, so many other more examples I could have shown. All you're going to do is carefully attach it to the main body. Be careful of the pins. So like I say, just wrap the tape right round the complete base, just above board level. And that's the first stage, what you're looking for. So it's nicely wrapped round just above board level. All you got to do then, just tuck the ends in. Again, be careful of all the pins. And then you're looking to just turn the sides over. And just tuck them inside. We'll do this side first, and then we'll just do this one, tuck this one over. And just turn my tweezers over, and I can just gently push that centre piece down, just to stick the centres down. And that's all you're doing. So no damage to any pins. It's nicely enveloped, so you've got a complete sealed connector there with a tape, and you're going to get a lovely result when you conformal coat this. Right, so now we're ready just to coat the second example now. Again, as you can see, I've got the 3M851 tape all around this connector. Made a nice fold over the top, so the whole connector is basically enveloped underneath that. And that should give us good protection. Anyway, let's get the coating applied around this. So I'm just going to do this, the surround of this. I'm not doing the rest of the board. It's mainly just showing you how protective this tape is and how good it is at leaving you a lovely finish. Let's just go around four sides. That's that side. Liberally over the pins. Just do the other side. Just coat some up there. And right against the connector body. The tape's going to do a good job, protection. You won't get any leakage under this if you've applied it properly, the tape. So it's got that all applied all around. So that's what we do. Again, we'll let this dry, and then I'll return when we're ready to peel the tape off. I'll show a different angle when I take the tape off along the side, so hopefully you should see how easy this tape comes off, leaving a great finish. So what we do, I'll return when I'm ready to take the tape off when the coating is cured. Just as I showed you with the other example, as you can see, you've got the coating. I've applied it around the connector. It's going down onto the board. I've just done this for the video, just to prove how good the tape is. But I've got, yeah, quite an amount of coating around there. So it's going all around, as you can see. So it's going to coat your pins, but you won't get any inside this connector using this 851 tape. Right, so let's get this tape removed. As you can see, just if you look along the edge of the connector, the tape's just off the board. So If you can get it like that, that's quite important. So it's going to definitely remove a lot easier. So what I'm going to do first, I'm going to open up the top, and then we can just lift this up and then just take it off. That's what you've got to do. Just get that over the top. So hopefully you can see how clean that plastic is. Now I'm going to partly take this off this end, then I'm going to switch the camera angle. That's just the adhesive of the tape you can see coming up. So I've got a nice result there. Like I say, that's just the adhesive. I'm just going to zoom in, get that back in focus. So I've got no coating at all on this. That's literally adhesive from that tape. So what we do, I'll change the camera angle and then we get the tape peeled up. Right, so I've changed the camera angle. Well, now it's quite difficult this, trying to film it and get the tape off. So let's just grab this tape and just peel the whole length of the connector. Just peel it off. Hopefully you can see, I'll try and get that back in focus up the other end. Let's just take that tape all the way off. Right, I'm just going to try and get this focused in up the other end. So I've got no coating in there at all. So that's what you're looking for. So yeah, it's a great method. You're going to get great results. And as you can see, I've got no coating in there at all. Clean as anything. So that's how good this tape is. So like I said earlier, get yourself some of this and you're going to love it. Anyway, what we're going to do, I'm going to move on to the final tape within these videos and hopefully you'll enjoy that one. Right, so move on now to the final tape of the 4 that I'm going to show within these videos. I've left this one till last. It's probably the one I use the most often. This is aluminium foil tape. Now it's amazing when you're doing hot air rework. Definitely find this gives great protection on your PCB parts. You don't want to get damaged. So what I do, again, I'll show you a couple of demonstrations of this tape in action. And yeah, I hope you enjoy them ones as well. Right, so moving on now to the first example showing the aluminium foil tape. Now we're going to get this ball grid array removed here. Now all around all 4 sides you've got these 0402 capacitors, resistors. There's even a 603 resistor there. So without protection, this is going to take a fair while because this board's got a lot of ground planes etc in it. There's a big heat sink on the other side. So without protection, these small components surrounding the device could easily become dislodged, and yeah, it can get blown away, and it can, if you don't know the values for example, it can cause you a problem. So this is where I like to use the aluminium foil. It's going to give me great protection. It's one less worry when I'm removing the device. With Kapton tape you can still dislodge these components, so I would recommend using the aluminium foil. So anyway, let's get this taped up and start the removal process. Right, so as you can see, we've already protected 2 sides of the small components. So let's just get the other 2 covered over. Now this tape from Advance I showed earlier is actually adhesive lined. It's going to keep it in position. The adhesive is fairly strong, so it will take quite a lot of heat. Let's just get the one up the side done, then we're ready to start the removal. Just try and get it as close as you have to. Let's just get that pushed down. So that's all 4 sides, the small components protected. Now we can start the removal. So I've got my hot air gun set to about 400 degrees Celsius. So by covering them up, it's just one less issue that I may come across when removing this device. So you can concentrate solely on the device you're trying to get off. So now you will hear the hot air noise throughout, so hopefully you can still hear me sort of talking through. Right, let's start the removal. So it will take a fair while, like I said, because of all the heat sink on the other side for example. Just gently circle the device. Just be patient with these. So you haven't got to worry about the parts underneath the tape, they'll be fine. Just let the heat travel right around the device. every so often I just like to try it to see if it's becoming looser. Just give it a bit more. So it's a good test of the tape, the length of time this one takes. Just be patient. Some devices come off a lot quicker than this one, but it's because of all the heat sinks on the other side. Shouldn't be too much longer. So just be patient. There you go, that's got all them, the balls are still intact, the components come off nicely. A small short down there, but that can be cleaned up after. So as you can see, that took quite a while to get that off, so let's peel the tape off and see how the components fared. As you can see, perfect on that side. Again, perfectly kept in place. So as you can see, they're all going to be fine all the way through. Let's just get the last one removed. So I've got no dislodged components throughout that whole rework process, and that's how good the tape is. So as you can see, that one took a long time because of the makeup of the board, and yet nothing's become dislodged around it. So yeah, if you're taking components off like this, get yourself some aluminium foil. So the advanced one's really good, it's not too dear, widely available online, and it's because it's the adhesive line, it's really going to help. And the adhesive comes off really easy just with general PCB cleaner. Anyway, what we do, I'll just show you one more example of the foil tape. I'm just going to do a plastic connector to see the great protection it gives on that, and then we'll finish the video up with a few photos. Quickly, I know it's diversifying away from the subject, I just want to show you how I clean up the BJ pads after. It's got my solder braid on there. Just literally drag it across. I do 2 rows at a time, and that's going to, as you can see, both of them first two rows perfectly clean, and I just repeat the process all the way across, and then just get all the flux off with ultra sold clean fluid. Then I'm ready to mount a new device. So anyway, like I said, we'll just carry on to the next connector, next example, the foil tape, and then put a few photos up. Right, so just show you another typical example of where I like to use the aluminium foil. Is when on this board here, for instance, I've removed this IC, got this close by plastic bodied connector. Now this is quite prone to melting, this type of plastic, so that's one that I would protect with a foil. I'm just going to quickly show you how easy this plastic is to melt, and then I'm going to take another board exactly the same as this one. I'm going to remove this IC, and on that board I'm going to protect this connector with the foil, and you're going to see how good the protection is. So on this one, so I'm just going to bring the heat gun in and just melt that plastic deliberately to show you how quickly it can melt. So as you can see, the top of it bubbling up really quick. And that's obviously the heat's not being applied for too long, and you already can see the damage all the way up the side, and that's how easy it is. So if you were heat gunning this to remove that IC, that's what you can do to your close by plastic bodied connectors. So what I do, like I say, I'll bring the exact same type of board in, I'll get that IC removed with the connector covered in the foil tape, and yeah, hopefully get good results. Here, got the exact same board as the last one, yet this one's still got the IC in place. This is the connector that we've just previously shown how easy it is to melt. So we're going to get this IC removed. Because I've foil taped up this, we'll get the foil off after and just look at the connector. Now I'm using the exact same temperatures as the last one. The hot air gun's going to go close to the connector. So yeah, let's get this off and have a look. So again, you will hear the air noise. So like I say, I'm just going to go as close to the connector as the last one. So I'm circling the area so it gets the connector as well. Hopefully it'll take a fair while, and then it's a good test for the foil. So depending on the makeup of your PCBs, ground planes, etc., some components can take quite a while to get off. We'll just circle both sides. There we go. Right, so that's come off fairly similar time to the last one. Let's just get the foil removed, and you've got a perfect connector. Now as you can see, no damage at all to that, all the way up. So that's how good the foil is. So without adding that foil, that connector would have definitely melted like the first example. So anyway, what I do, like I say, we've finished the video here. Thanks a lot for supporting my channel as always. We'll put a few photos up what we've done, and I'll see you in the near future with some more soldering videos. So thanks a lot and take care.